All right. So welcome back. So I hope all of you are already here so that we can now continue our discussion. So 21. How many are we in part 1?
32.
22. So there's one who haven't joined yet. Okay,
No,
anyway,
32.
32. So
Yeah.
there's 11 who haven't joined yet or who didn't go back in part 2. Anyway, it's okay. So let's continue now since we've already waited long enough. Okay, so this is example number 1. Okay, so check first the construction and then the things that you'll see. So this is a constant, okay, and then we have a exponent that is 2x plus 1. This is basically a function, okay. So it would fall under logarithmic, not logarithmic, exponential, okay, function, okay, wherein it's this one, okay, the one that has a constant as our base. Okay, so in here it's derivative of a raised to u, which is basically this one. Our a is 3, the u is 2x plus 1. Okay, so yeah, as long as you know the formula, it's equal to a raised to u ln a derivative of u, then I think you're good to go. Okay, so a and then u is still the same as it is. Just simply copy it as it is. And then here's another thing that you guys need to add. So ln and then a, which is 3, and then derivative of your u, which is 2x plus 1. Then afterwards, copy this one as it is. Oops, wait. Why is it became why did it became 2? Okay, let me just check. Laundry, it's still the same. Hmm. This one seems suspicious. Okay. Maybe it's a typo because supposedly this one's still 3. Okay, let me just edit this one real quick so that once that I will upload this one, you will get the correct uh value or answer. Then yeah, 3 times 3 is 9. Yeah. So if this is 2, you won't really be able to get 9 since in here 3 times 3 is 9 and then the rest are still the same. Or is it? Wait, let me just check. It's equals now to ln 3 squared. Well, anyway, we'll see later on if 3 is really incorrect, but I think 3 here is the correct one. Okay. Maybe it's just a typo. All right, so let me just erase everything so that we can go back to the new one or from fresh. So this is still the same. This is still the same. Derivative of 2x is 2. Derivative of 1 is 0. Okay. And then it says you're applying properties of logarithm, and log a is actually equals to log a raised to n. Okay, you can actually transform this one into, oh, so from 3. So if you're going to use this one, and then from here it is saying that this 3 ln 3 could be transformed into like this. However, a while ago this one is 2. Okay, let me just check why this one became 2. Supposedly it's still 3 because, you know, it didn't say that we have to reduce it by 1. Let me just verify. It's 2. Hmm. Why did it became 2? Unless it's really a typo, you know. I think it's really a typo because there's no way that, you know, the A would became A minus 1. Okay, there is no minus 1 in here. Okay, saying that it should be minus 1. So I will stick with 3, and then let me just edit this one real quick. And this is now 3 raised to 3. Oops. There you go. And then, oh, wait. Wait. Still there. Ln 3 derivative. Ooh, I see. Okay, this one should be 3, and this one should be really 2, but this one is still 3. Okay, so I'll explain why later on. And this one is 3 squared. And this one is 3, because it's still 3 in here. And 3 squared is 9, and this one is 3. Okay, there you go. All right, so let's go back here again on this part. So again, we just simply plug everything. Derivative of u, which is 2x plus 1. Derivative of 2x plus 1 is just simply 2. Okay, you can actually place this 2 right here. Okay, making it 2 ln 3, which is now this one. And this 3 raised to 2x plus 1 is now this part right here. Okay, so we just simply rearrange it. Okay. And then according from the property or properties of logarithm, okay, n log a is equal to log a raised to n. You can actually make this as your exponent. So vice versa, of course. If you're seeing an exponent, you can bring that one down and making that one as a constant or as a base. Okay, the same thing with ln. Okay, they're just the same. And ln a is equal to ln a raised to n. You can make that one as exponent, or you can bring this one down, which we'll just go back to this one. Okay. So in here, what we want to do is uh where is that one? So make this one as your exponent. Okay, which is now this part right here. So let me just put a space so that they are not really, there you go. All right. So let's go back here. So 2 ln 3 became now ln 3 squared. 3 raised to 2x plus 1 is still the same as it is. Okay, so in here you can simplify this one by simplifying the 3 squared. So 3 times 3 is ln 9, which is now this one. And then this one is still the same as it is. So this is now your final answer after rearranging it. Okay, so again, you can put this one before the ln, and then place this one to the right side, which is now this one. And then you can make your base as your exponent, and then suddenly 3 squared became a 9. And then the rest is still the same. Okay, so were you guys able to get this one so far, the number one?
No, can you please explain it again? Because it's confusing.
Okay, so let's go back from the very start. Okay, so this is the given. This is your A. This is your U. That's the exponent, right? Since it has the same, characteristic, so we can use this exponential function formula. So your A is still this 1, and then your U is 2x plus 1. Now, just add this 1. So we have ln, and then the A is still 3, and then derivative is still derivative, and then U is 2x plus 1. Are we clear on that part? You just simply plug
Yes,
in
yes.
everything. Now, since we now have this part, so the computation that you need to do is this derivative part. Okay, derivative of 2x is 2. Derivative of 1 is 0. Supposedly there's 0 in here. But of course, since it's 0, you can just simply remove it. Okay? So are we clear? And this part,
Yes, yes.
everything's still the same. We just derive this part. Now, afterwards, again, you can place this 2 in here. Okay, making that one 2 ln 3. And then this one is still the same, it's still 3 raised to 2x plus 1. It's just that it's now on the right side. We just simply rearrange them. Okay? Are we clear in this part?
Yes, yes.
Now, from based on the logarithmic formula, okay, it's n ln a. Okay, it says here that we can actually make this one as your exponent, which is now equal to ln a raised to n. Okay, so that is why from 2 ln 3 it became ln 3 squared. Okay, that's a property of a logarithmic. Okay, and then this one
Okay.
is still the same as it is. Just simply copy it and then place it right there. Now, ln 3 squared can be still simplified by, of course, multiplying 3 to itself. 3 times 3 is 9 because 3 squared is 9. So making that one ln 9, and then this one is still the same as it is. Okay, so are we clear so far?
Yes, yes.
Okay. All right, so that's it for the number 1. Now let's proceed to number 2. This one is still the same as, having a constant, which is 4, and then the sine x is your u. Okay, so we'll just follow the formula. A is 4, u is sine x, ln is ln, a is 4, derivative is derivative, and then u is sine x. All right, so let's go down, and then let's see what will happen. And here, derivative of sine x is cosine x. Okay, so have I already given? I think we already have a copy, right? Sine is cosine. Here, derivative of sine u, okay, is cosine u du. Okay, if we're going to go back here, derivative of sine u, okay, which is sine x to be exact. Okay, derivative of sine u is cosine u derivative of u. Okay, so let's see what will happen. So derivative of sine x is cosine u is x, and then derivative of x, which is equal to 1 to be exact. So cosine x, okay, derivative of x is 1. As to y, it's still cosine x. Okay, are we clear? So what is the derivative of sine x again?
Cosine x, derivative of x.
Yeah, this one. Okay. So as to y, we just simply copy this one as it is, sine x, ln 4, and the derivative of sine x is cosine x. Okay, and that's already your final answer. Okay, so are we clear on this example number 2?
Yes, sir.
Yes, sir.
Okay, very good. Now let's proceed to example number 3. So this one would fall under this exponential formula. So it's e raised to u. Okay, so let's see, e is e, u is square root of x. Okay, that is the case, then we just simply plug in this given formula. So e is e, u is square root of x, and then derivative is derivative, and then u is square root of x. Okay, so in here we just simply derive that is square root of x. Okay, so let's see what will happen here. It's equal to e square root of x times, yeah, okay. So in here, let me just go here so that I could show this one once again. We actually already have this example a while ago, but yeah, let me just repeat it. So square root of x is equals to x raised to 1 half, correct? And then the derivative of this one is using a power formula. So bringing down the exponent, okay, retaining the x, and then 1 half minus 1 is now equals to negative 1 half. Okay? And this one can be transformed into 1 over 2 x raised to 1 half. There you go. Then again, x raised to 1 half, you can bring that one back into an square root. So 1 over 2 square root of x. Okay, which is now the same with this one. Okay, so that's how we derive square root of x. So we just simply copy this 1. Okay, and then once we derive it, it's now 1 over 2 square root of x. Okay, and then just multiply. E squared, e raised squared of x times 1 is e squared, e raised squared of x, and then over 2 square root of x. And this is now your final answer. Are we clear?
Yes, yes.
No, sir. Can you
Yes,
explain
sir.
again?
Come again? Are we clear? Or anyone who has a question? Yeah. All right. So just let me know if you have a question. So let's proceed to example of logarithmic function. Okay. So let's see. So this is the formula of the logarithmic function. So we have the log and then the base and then the function. So we have the log, we have the base, and then the function. Okay, so if that is the case, then we can just simply use this formula. So derivative of your u, which is 2 minus 3x, over u is 2 minus 3x, and then ln is ln, and then a is 5. Okay, and then the derivative of 2 minus 3x is negative 3. Okay, and then you do not touch the denominator. This one is already your final answer. Okay, so did we get the number 1?
Yes, yes.
So what did you notice, Ibrahim? Mohammed Abdul
I
Ibrahim.
noticed like that it's what do you call it? It's like the derivative of the constant over a variable. Like it's have the same formula.
Same formula. Well, one thing
Yes,
that I
something like that.
okay, one thing that I could say is that I would say 90% memorization, a little bit of simplification, and then analyzation, you'll be able to get the correct answer. Okay, so this is one. Just memorize this formula, and then you saw that format. Just it's just about deriving the function, and then if you were able to get the correct derivative, and then that's about it. We do not touch the others since we just plug in everything. Okay. So all this time from the very start when we are start deriving, we're always 100% reliant on the formula. So if you can memorize all the formulas, I would say that you will really pass this subject. Okay. All right. So let's proceed to number two. So we have here y is equal to ln cosine 2x minus 1. Okay. So we have ln in here, and then the rest is already a function. Okay. We have the ln, and then the u is the cosine 2x minus 1. So if that is the case, just use this formula. Okay. So dy over dx is equals to 1 is 1, and then the u is cosine 2x minus 1, and then the derivative of your u, which is cosine 2x minus 1. Okay? And then in here, we do not touch this one. Okay, all we need to worry about is how to derive this part. Okay? So in here, cosine, the derivative of cosine again is negative sine. Okay? Just in case that you forgot. Okay, derivative of cosine is negative sine u du. Okay, sine u du. Okay, let me just write here. Derivative of a cosine u is equals to negative sine u derivative of your u. Okay, so in this case we have negative sign, that is the first one. Okay, and then the u, okay, which is the 2x minus 1, and then the derivative of your u. Okay, your 2x minus 1. Derivative of 2x minus 1 is simply 2. Correct? So let me know if you have a question. So once you've got this part, okay, you can rearrange it. You can place this one in front. So it's negative 2 sine 2x minus 1 over cosine 2x minus 1. Okay? So you might think that you can cancel out this one. Okay? No. Okay? Just leave it as it is. Okay? That one is already your final answer. Okay? So are we clear in number two? So any questions so far?
No, no.
Okay. All right, so let's proceed now to the next example. So we have here y is equal to e raised to ln 2x. Okay, so we can use again this formula. Okay, we have the e, we have the u, which is ln 2x. So e is e, u is ln of 2x. Okay, it's still the same. And then the derivative of your u, which is ln x. Okay, so in here, the derivative of ln x is actually base in here. Okay, so let's go back to this formula ln u. Okay, and then ln u is equals to 1 over u, okay, which is this x right here, 1 over x times the derivative of your u, derivative of your x, okay, which is this 1. And the derivative of x is just simply 1, correct? So 1 times 1 is 1 over x. So this entire here is now this 1. E raised to ln of 2x is still the same as it is. And then simplifying this one further, just multiply this one side by side. Okay, you will get e raised to ln 2x over x. Okay? Now, so one property of a logarithmic or logarithm is e raised to ln a is equal to a, or a raised to log a. A again, okay, it's just that the differ in capitalization is just simply equal to a. So it's trying to say that this is just simply equal to 2x. Okay, based on that logarithm. Okay. Well, basically, if we are going to follow that one, it would be true. Okay, because e raised to ln a, okay, is just simply equal to that a. Okay, so that a in here is this 2x in here. So if we're going to follow this properties of logarithm, this e raised to ln 2x is just simply 2x. And then over x is still over x, which is now equal to 2 because x will cancel. Okay, so we call this one the number raised to log. Okay, so a raised to log a raised to x is just simply equals to x. All right, so are we clear so far?
Yes, yes.
Okay, so I would like you guys to study. Okay, so of course we only have 1, 2 examples per topic. Okay, so I would like you to search more on the internet, let's say 3 examples per topic so that you would understand more, okay, about that specific topic, okay, or about that formula. Okay, so our midterm exam is the second week, so basically we now only have like, practically 2 weeks left to be exact. Okay, since next week is already 27, and yeah, it's like 2 more weeks. It's now like 8 more meetings left, and then we're going to have a few more quizzes. So we now only have a few more discussions meetings left. Okay, so we'll just continue this one next week, Monday. Okay, and after that, we're going to have a quiz of this trigonometric or inverse trigonometric function. All right, so that is why make sure to use the remaining days, say from Friday to Sunday, to review, do an advance reading, do an advanced review so that you would be able to understand more of the topics that we have discussed. So for now, that would be all. So we'll just continue this one next meeting since we don't have that much time anymore. So yeah, okay, that's all. So goodbye and see you guys next week.
Thank you and goodbye, sir.
Right. Thank you and
Thank you,
goodbye
sir.
to
Thank you, sir.
Thank you, sir.